This lesson will talk about empirical formulas and how to get the empirical formula and the molecular formula if we have percent composition. So first we have to talk about what is empirical and what is molecular. So we'll just take a couple of examples. We have a compound that exists that is C2H6. If you look at that formula, it is possible to simplify it. If I reduced it, took each of these numbers and divide by the smallest, I could get this. This would be the simplified version. This is the reduced version. This would be the empirical formula. This is the actual formula. The molecular formula is the actual one. The empirical formula is the simplified version. All right, let's take a second example. This is hydrogen peroxide, H2O2. This is the actual formula for this compound. But once again, I could simplify it. I could reduce it. I could reduce it to H1O1. So this would be the empirical, but this is the actual formula. What about this example, CO2? Is it possible to simplify this one? No. This is the actual formula, carbon dioxide, but I can't simplify it. So in this example, the empirical formula and the molecular formula are the same thing. So sometimes we can simplify, but sometimes we can't. So that's what those are. Right, we just got done doing percent composition. We can take that information to help us find the formula for a compound. All right, the formula that we get is always going to be the empirical formula. But with that information, we can also figure out the molecular formula. So why is this important? Why do this? It's important because if I have a beaker that has an unknown compound, if I can find the percent of the elements that make it up, I can take that information to figure out what that formula should be. And if I can figure out the formula, I can identify the compound. So let's start. I happen to have a compound, and I have a balloon filled with air. Let me get rid of that. So here's my balloon filled with air, and or filled with a gas, I should say. And in that balloon, I have been able to figure out that I have 12%. Oops. I'm sorry, I'm reading the wrong information. Right, so the gas in that balloon is 43% carbon, and it is 57% oxygen. So I need to figure out, well, what is the gas that is in there? Is it carbon monoxide? Is it carbon dioxide? Is it some unknown gas I don't know about? What is that compound? So I'm going to take this information. If I had 100 grams of gas in that balloon, and 43% of it was carbon, that means that I would have 43 grams. And out of that 100 grams, if 57% is oxygen, that means I would have 57 grams of oxygen. Okay, that's the first step. The second step, I now have to figure out how many moles of each of these I've got. Well, anytime we have to find moles, we have to go back to our periodic table. So here's carbon, here's oxygen, and I have to look up the mass for each. So the mass of carbon, if I had 1 mole of carbon, it would have a mass of 12 grams. So that's going to cancel. Now I know how many moles I've got. I take 43 divided by the 12, and that gives me 3.58 moles. All right, the same process for the oxygen, 57 grams. I look on the table and I see that oxygen has a mass of 16 grams if I have 1 mole of it. Obviously, I have more than 1 mole. 1 mole is 16, I have 57. So if I take the 57 divided by the 16, I get 3.56. So that's how much oxygen I have, that's how much carbon I've got. The next step, I have to get a ratio, a simple whole number ratio. So I do that by dividing both of them by the smallest number. Right, well, this is obviously going to give me, right here, divide by the same number, that gives me 1 oxygen. This right here is going to give me 1.005 carbons. So that's my ratio. This is close enough to 1, I can just round it off. So I'm going to round that off to 1. So my ratio for this compound is 1 carbon to 1 oxygen, or the compound carbon monoxide. Right, let's do a second example. This time in that same balloon, this time I have 27% carbon and 73% oxygen. So I have to go to my table again to see what the mass of carbon and oxygen are. And if I have a 100-gram sample, that means that 27 grams will be carbon and 73 grams will be oxygen. And the table tells me that 1 mole of carbon has a mass of 12 grams, and 1 mole of oxygen has a mass of 16 grams. All right, so my grams are going to cancel. Now I got 27 divided by 12, and let me do that quickly. That gives me 2.25 of the carbon, and 73 divided by 16 gives me 4.56. So that's my ratio, 2.25 to 4.56. Well, I can't hardly have 2.2 carbons and 4.5 oxygens. I either have a whole carbon or I don't. I have a whole oxygen or I don't. So I am going to have to take these ratios and I have to divide by the smallest number. So that I always get 1, and when I take that 1 divided by 2.25, I get 2.02. Well, again, this is close enough to 2 that I can just round it off to 2. So that now gives me a ratio of 1 carbon to 2 oxygen. So here is that formula, 1 carbon to 2 oxygens. So that's how we can use percent composition. Right now, if that problem happened to tell me that the compound, let me just erase some of this. So here's what I got, and I know for sure that this is the empirical. Now, if it were to tell me that the actual weight or mass of that compound was 88, I would have to check to see if the empirical formula is different from the molecular. So to do that, I would have to add up that compound. So 1 carbon is 12, oxygen is 16, but I have 2 of them. So that compound, CO2, weighs 44. It has a mass of 44. But the problem is telling me that the molecular mass is 88. So what could I do with a mass of 44 to get a mass of 88? I would have to double this. But when I double it, that means I have to double everything. So I would have 2 carbons and I would have 4 oxygens. So in this particular case, if I was told the molecular mass was 88, I would have to say, here is the molecular formula. What I found was the empirical. So anytime you do these problems, you always find the empirical first. Sometimes the empirical will be the same. If it would have said that the molecular mass was 44, I could conclude that the empirical formula was the same as the molecular. And that is it.